Okay, here's the promised lesson. I'll have to do another one for you tomorrow, but this one is lesson 37, chemical compounds and parallelograms. And I'll try to make this as painless as possible, although this lesson is rather long. I'm going to try to shortcut some things so that we're not here all day during this video. Okay, a couple things. We're doing chemical compounds, so you three who are in chemistry, this may be a repeat, so I guess you'll be happy about that. Chemical formulas for the compounds tell us the number of each kind of atom in a molecule of a compound. So you're saying, who cares? But anyway, if we look right here, we have, this is a compound, H2O. We all know what that is, right? H2O is water. So a water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. Here's another one, ZN3N. That's zinc nitrate. There's 3 zinc atoms and 2 nitrogen atoms. See the little 3 right here? That tells you how many zinc atoms are. Like the 2 here tells you how many hydrogen atoms there are in water. Every atom, so this is a molecule, H2O, and then it has hydrogen atoms and oxygen atoms. Each atom has a different weight, and they're in grams. So oxygen weighs 16 grams and hydrogen weighs 1 gram. When elements combine to form a compound, we say the molecules of a compound have a gram weight, gram molecular weight. So if you have a water molecule, it has 2 grams of hydrogen, and we saw up here that hydrogen weighs 1 gram, and 1 gram, one atom that weighs 16 grams. So oxygen, we have 1 oxygen that weighs 16 grams. So the total weight would be 2 times 1 would be 2, plus 16 would be 18 grams. So the molecular weight of water molecule is 18 grams. So with that information, let's try, we're going to do 2 problems. I'll cut them down from 2 to 3. You'll be happy to know. So let's just go here. The chemical formula for water is H2O. If we have 3,600 grams of water, what is the weight of oxygen? I do these differently than the book. I just do our old-fashioned ratio problems. So we have hydrogen, we have oxygen, and then we have the total. And that spells hot. So we have, if you go to this hydrogen atom, we have 2 of those, and they weigh, hydrogen is 1, it weighs 1 gram, so the total weight of the hydrogen atom is 2 grams. The oxygen, we only have 1 of those, and the total weight, this is where your weights will be written, it tells you oxygen is 16. So we have 1 oxygen atom, and it weighs 16 grams, so that would be 16. And we already knew the total, we did this one above, is 18. So you set that up like that, and then it says if we have 3,600 grams of water, so that would be your total. The total would be the whole H2O molecule. So we have our total is 3,600 grams. We want to know what is the weight of oxygen, which is right here, and that would be X. So you just set it up like a ratio, like this. And I'm going to reduce this before I cross multiply. How about that? 9 and 8. And so we would just get our calculator out, which I have to do right now. So we take 3,600 times 8. And that's my calculator went away. 28,800. Equals 9x, and divide both sides by 9, and we're going to get, divide by 9 equals 3,200 grams. So these are pretty easy. They're just making ratio charts, and I know some of you do it where you take 18 goes into 3600 and then take it times 16, and that's fine, you get the same answer. Okay, let's look at one more of these. The formula for ammonium chloride is NH, and I think I missed a number there. Let me see, NH4Cl. It's going to get complicated now. So we have our 4Cl. This means that there's one molecule of ammonium. In one molecule of ammonium chloride, there is one nitrogen or hydrogen and one atom of chlorine. How many grams of chlorine are there in 1060 grams of ammonium chloride? So we have to figure out the weight of this whole molecule first. So we would put our nitrogen. We have how many of those? We just have one of those, and it weighs, right here is the weight, it weighs 14 grams. So the nitrogen equals 14. The hydrogen, we have 4 of those, and each of those only weighs 1. So the nitrogen weighs 4. And then we have our chloride, Cl. And that one, we have 1 of those, and it weighs 35 grams. Boy, those are heavy. That's 35. So we know that the entire, it says how many grams of chlorine are there in 1060 grams of ammonium chloride. So this is the total ammonium, I can't even say this, H4Cl. That's a 4. So the total is equal to 1060. The one that we want to find is chlorine. So we want to find our chlorine, so we let that one be X, and we just set up our little ratio. So that would be X. And what did I just do? Let me just fix this a little bit. I put this in the wrong spot. Hold on. Okay, so I have to get the total here. 8 plus 5 is 13. Carry my 1, and so I'll get 53. Okay, sorry about that. So your total is just adding these up, and we want to find out how many chlorine in 1060 grams of the whole thing. So we just set up our little ratio here, and we're going to cross multiply and do all that, and we should get that the chlorine equals, so they really do it crazy way in the book. So we're going to get the chlorine, if you cross multiply and divide by 53, you get 700 grams. And that's how many equals the chlorine. That's how much it weighs. So hopefully that's not so hard for you. It's just setting up your ratio. You have, just like what we had before, we have our total column, so you total up all the weights, and then we have, if there were 1060, how many chlorine would we need. So hopefully that's clear. If not, we'll cover that in class on Thursday. The second part of this lesson is on parallelograms. This takes a little bit of memorization to do this one. I don't think I have a big enough little box here to cover this. Okay, this is a parallelogram, and there's 4 special properties of parallelograms that you have to memorize. There's proofs in the book if you want to look at the proofs of them, but I knew you wouldn't want to watch a 30-minute video for these. Okay, they have special properties. We can look at this parallelogram down here if you want to look at a parallelogram while I talk. Parallelogram. Okay, the 4 special properties are the pairs of parallel sides have equal lengths. So this side is going to be equal to this side. And we also know that this side is going to be equal to this side. So pairs of parallel sides have equal lengths. The other thing is the angles opposite each other have equal measures. Angles opposite. So I'm going to go back to this one. So that means that this angle is equal to this angle, and this angle is equal to this angle. The next one, number 3, is the sum of any two adjacent angles add up to 180. So that means if this one is A and this one is B, then we know that A plus B is going to equal 180. These are adjacent angles, and you can see if we extended this and made these parallel lines, these are interior angles between two parallel lines, and they are going to always add up to 180. And the fourth one is the diagonals are going to bisect each other. So if I put diagonals in this one, here we go, let's add some diagonals. Here's a diagonal. I'm really making a messy parallelogram. So we know that they bisect each other. It means that this side is equal to this side, and this side is equal to this side. The diagonals are not equal, but they do bisect each other. And that means that this one is equal to this, this one is equal to this. Okay, obviously there's going to be some problems that we can do with parallelograms. So let's look down here at example 3. ABCD is a parallelogram. I made this a little bit too fat. Here's a parallelogram. We have some things. This is ABCD. This means the sides are parallel with these lines through it. We have this side is y plus 7. What else do we have? This side right here is x plus 2. Right here is x plus 2. This one's 7. And the angle BAD right here, let's see, I didn't write. This one right here is equal to 65. Your goal is to find a measure of ADC, and DCB. Well, we can go about it two different ways. According to rule property number 2, angles opposite each other have equal measure. So we would know that BCD, which we don't even care about, so let's not do that. Yeah, BCD, we do. BCD is also going to be equal to 65. So we can say the measure of angle DCB is going to equal 65. Then we know that this angle and this angle have to equal 180. The same thing here. This angle, which is the same as this angle, and this angle right down here, this angle and this angle have to equal 180. So we would say 180 minus 65 is going to give us angle ADC. Okay, because this angle plus this angle has to equal 180. So if we take 180 and subtract this 65, we're going to get this angle. So we're going to get the measure of angle ADC is equal to 115 degrees. Oops, DC. Alright, sorry to bore you to death. Talon, Karis, and I just did an exercise video in the basement. Okay, so now we need to figure out x. We know that since the special rule is diagonals bisect each other, so we know that this is equal to this. So this side is x plus 2, and it's equal to this side, which is 7, so we know that x is equal to 5. And I think I might have missed putting something in the problem. Yeah, this is y plus 7. This is y, no, not y plus 7. Oh, I wrote y plus 7 in the wrong spot. This is y plus 7 right here. So we can write another equation. Y plus 7 has to equal 4. This is equal to this. So y plus 7 equals 4, so y equals -3. And that's how you do those problems. The hard part for these is you really have to memorize the 4 special properties of parallelograms. Okay, last problem, we'll just breeze through this one. This one just has angle measurements, and according to the special property 3, the sum of any 2 adjacent angles is 180. So these two are adjacent, so we would just write 10x plus 50 plus 5x plus 10 equals 180. And we would get 15x plus 60 equals 180. 15x equals 120. And we would divide 120 by 15. How do you like that? 20 divided by 15 equals 8. So x equals 8. And then we can figure out what y equals. We have to put this 8. Stay with me here, we're almost done. This is the last problem. We're going to put that up here in for the x. So we're going to get 10 times x would be 10 times 8 is 80, plus 50 is 130. So this angle right here is 130 degrees. So what that tells me is this one also needs to be equal to 130. So we know because opposite angles in a parallelogram, that's rule number 2, have equal measurements. So y plus 10 equals 130. And we just solve it for y, so we get y equals 120 degrees. Hopefully you find these to be a little bit fun anyway. And that's it. Okay, that's it for lesson 37. Sorry it was so long. And I'll get you lesson 38 tomorrow.